Okay, so I'm going to record the lab directions for the people who are not here today. So if I seem to be pausing and starting and stopping at weird times, that's what this is about. So today, the first thing you're going to do is to go back and find your 4 chromatography strips. And then you're going to attach them into your laboratory notebook. Either if there's, you've been doing the 2-column thing with your observations. If there's room on that last page where you can attach the strips, that's fine. If not, draw an X, initial it, and then go to the next page and attach your 4 strips. You may use tape, you may use staples, you may use glue sticks. I'll have to get the glue sticks out. You can use any method of attaching them that you want, but you want to attach them on the top sheet, on the original sheet, okay? Now, mistakenly, I thought that the ethanol or the isopropanol was the better eluent, but I was wrong. So you're going to use your data, and then you're going to use some data from the other class that used the 2% sodium chloride, and we'll actually get to compare the 2 eluents. So you're going to have 2 data tables just like in your lab handout. Okay, so you're going to attach your 4 strips, and then you're going to make 2 data tables. You're going to write data tables, and then underneath you're going to write table 1, and you're going to make a table that looks like this. And then table 2, you're going to make a table that looks like this. Does that make sense? Okay, so then do that, and then I'll, as soon as everybody has that done, has their strips affixed into their lab notebook, and they have their 2 data tables drawn up, then we'll talk about how we're going to fill in the data tables, okay? Okay, so now that we've got our data tables constructed, what we're going to do is we're going to go ahead and we're going to record our data in table 1. Now, we did a separate strip for each of the dyes, for the 3 known dyes and then the 1 unknown. And so the way this table is set up, it's got a place for the solvent. This is as if we did it all on the same strip of paper. So there's a place for only 1 solvent front. So what we're going to do is we're going to just disregard the solvent front. And for each dye, we're going to put the how far the dye went to the middle of the dot over the solvent front. We're just going to make a fraction. Okay, so we're just going to divide our boxes like that. Okay. And of course, in sample 4 was a mixture, so you're going to have more than 1. You're going to have to kind of squeeze it in there. Okay. So if you have not measured your solvent, how far the eluent went and how far the dye went, you are welcome to grab a ruler and do that right now so that you can enter your data. And then after everybody has that in, then we'll talk about calculations and how we're going to finish the other data table, okay? So if you look under modules, labs, this document is basically how to write your lab report. This is what we talked through the other day. So this is there for reference. Anytime you are setting up a lab, getting ready to write a lab report, this is kind of your guidelines, okay? So the other day when we set up the lab notebook, we talked about the pre-lab. So notice that these 6 items, that's all part of your pre-lab. When I ask you to do a pre-lab for a certain experiment, that's what I expect you to do, is those 6 things. And then there's a whole lot about collecting data, and we'll continuously talk about these as the year progresses because this is important all the time. So how do you collect data? What do you write down? And I think most of you did a good job so far. Yeah, yes? Okay, all right. So then underneath here, we've got our data table, and now we've got calculations. And so generally we do not want you to show every single calculation if it's the same calculation. We want you to show a sample calculation, all right? And here's what goes into a sample calculation. So in this case, you're going to be doing RF values. And so you would want to identify what it is that you are calculating and what trial it is. So you might want to say, for you might want to say red dye, 2% isopropanol solution, RF factor, okay, or RF. So you want to identify what it is that you are calculating. And so you want to, underneath where your data tables are, you want to make a heading, calculations, and then you want to identify what the calculation is. Then you want to write out what you're doing in words. So in this case, we're figuring out trial 1, the mass of the sodium bicarbonate solid. And so to figure that out, we're going to take the mass of sodium bicarbonate in the crucible before heating minus the mass of the empty crucible, and that's going to give us the mass of sodium bicarbonate. So we're writing out in words what we're doing. So the measured distance of the dye, you don't have to go into exactly how you measured it, but the measured distance of the dye over the distance of the eluent, right? So you're going to write that. Then you're going to actually do the calculation, putting the numbers in and finding your answer with units. Okay, since all you're doing are calculating RF values, you only have to do one calculation to show me that you know how to do the calculation. The rest of them you're going to do and put them in the data table. Okay, but you don't have to show your work for every single calculation in the laboratory notebook. But those are the 3 parts of a calculation that you do need to show. All right? Any questions about that? Yes? Say this again? Yes, that's absolutely fine. Yes, you may go to a new page if you feel like that's going to make your lab report more readable. So I'm just going to finish talking about how you want to wrap up the lab. After you have your data tables filled out and you have your sample calculation, then you're going to write your conclusion. And so you're going to restate the purpose of the lab and summarize your results. So what did you find? One of our findings was that the 2% sodium chloride solution did a better job of clearly distinguishing the 3 dyes than the isopropanol. So that's one conclusion. Other conclusions would have to do with the intermolecular forces between the dye and the paper and the dye and the eluent or solvent, which looking at how far it traveled down the paper is going to tell us something about what it's more attracted to. Is it more attracted to the solvent or is it more attracted to the paper? Each of the dyes is different, right? And so you should state some conclusions about that. Then you should think about any errors. So an error is not a mistake. A mistake is something that you really should have gone back and done again. Like if you spilled something or you forgot to weigh something. Those are mistakes. Errors are more inherent in the lab. So the way we took data or assumptions we may have made. We are going to do a lab later on this year where we look at the molar mass of a gas and we make an assumption. We make an assumption that the temperature of the gas is the same as the temperature of the water that we're bubbling it through. We're not directly measuring the temperature of the gas. So we're making that assumption. And that will affect our results, right? Because we're making an assumption. We're not actually directly measuring. So you should think about any types of errors inherent in the lab and how you might, how it might affect your data and how you might correct for that. Don't write that this lab was successful. I like this lab. You don't need to do that. Okay, this should not be an overly long section. I would say maybe 4 sentences. It should be written in third person past tense. This should be in paragraph form. So you should write your conclusion as a paragraph. Now for this particular lab, we have something to do after our conclusion because this, let me find it here, where it talks about analyzing evidence. That's really our conclusion. You're going to have an additional section interpreting evidence. You can go ahead and label it that, label the section interpreting evidence. And then you want to answer these questions. You do not have to answer question 3. I just want you to answer questions 4, 5, and 6. Okay? So you're going to answer questions 4, 5, and 6. And we're going to do the AP Chemistry review questions on a separate document, so don't worry about those. Okay, so after your conclusion, answer questions 4, 5, and 6 under the heading Interpreting Evidence. Does that make sense? Okay, so generally I give you a week after our post-lab discussion. So this is our post-lab discussion. In the future, post-lab discussions won't take as much time because I won't be coaching you through like all the steps. So the post-lab discussion is sometimes maybe half a period or so, and we'll talk about it. And then you have a week to get everything together. I am not going to keep reminding you that it's due. You just need to put that on your to-do list and be aware that it's due in a week. Okay?